Hello everyone, welcome to the discussion. In the today's video we are going to talk about the t-test. तो सबसे पहले how to identify that the question wants us to perform the t-test. कब पता चलेगा कि क्वेश्चन जो है उसमें t-test बायोस्टैटिस्टिकल एक्सरसाइज हमें परफॉर्म करनी है. So t-test is applied when the sample size is less than 30. तो greater than 30 में क्या अप्लाई होगा? As we taught in the previous video, if the question set is greater than 30 then there will be a z-test. If it is less than 30 then there will be a t-test. Now what will be greater than or less than 30? The sample size we are talking about. Now if there is a too much data in the question, like tables are given, like before after studies is written in the wordings of question, so it will be likely that the t-test should be performed in that question. And once again, that is 2 by 2 table is absent to rule out the chi-square. Now what are the types of t-test? So t-test is basically divided into two types, that is paired and unpaired. Now for the paired t-test, if only one group is present, then we have to make sure that paired t-test will be applied. Why we are studying the types? Because there will be the different formulas which will be applicable for different types of the t-test. So has written, that is if one group is present then paired t-test will be applied. For example, how to we get know that in the question they are talking about only one group? So in the question's wordings it will be given that there is a before after studies, means only one group is present. For example, they are conducting a blood pressure studies for a drug clinical trial in which there are 20 people, okay, in which there are 20 people. So we are saying that before giving the drug there is a blood pressure and after giving the drug there is a blood pressure. So in fact we are recording two different blood pressure. The 20 people will remain the same in the group. So in that scenario we are telling the paired t-test. Now how to remember that in the one group there is a paired t-test? So this is a mnemonic which is given by the Arpit PSM, that if single person is there it needs GF. So what single person wants? Single person wants pairing. So if there is a one group is present then it will be a paired t-test. Now what are the formula which are applied in this paired t-test? For the paired t-test, t is equal to d into root n divided by standard deviation. What is d? D is a difference which will be taught in the examples, upcoming examples, whereas the standard deviation which is written here is equal to root of sigma d minus d bar whole square divided by n minus 1, whereas the d bar is actually sigma d by n. Now we have to just remember these equations because it will be applicable in the questions, so there is no chance to skip it. Now second type, that is the unpaired t-test. If two groups are present then the test which will be applicable is the unpaired t-test. Now how do we know that the question wants us that there is a two groups which is present in the question? So in the question wordings it will be written as two types of group are present, or another group, like another group B is fed some diet B, like such the question wordings will be there. Now how to remember that for the two groups unpaired t-test is done? So similarly, like in the paired t-test, the single person wants girlfriend, the single person wants pairing. So here in the relationship, the person wants to be alone. He doesn't want to be paired because he is already paired. So in the relationship, that in the two groups, if two persons are present, they needs unpairing. So similarly, here also if there are two groups, unpaired t-test will be applied. Now what are the formulas for the unpaired t-test? For the unpaired t-test, formula will be t is equal to x bar minus y bar divided by standard deviation under root of 1 by n1 plus 1 by n2. It is not x similar but somewhat like the z-test formula only. Then where the standard deviation which is written here is what? It is root of n1 sd1 square plus n2 sd2 square divided by n1 plus n2 minus 2. I know that it will be some problem while learning this, but at the end we have to remember the formula. Now what is the degree of freedom? This is an extra step which we have to write in the question and in the questions in the answer sheets has a step. Now degree of freedom for the paired t-test, the formula is n minus 1, whereas for the unpaired t-test the degree of freedom is n1 plus n2 minus 2. Why n1 plus n2? Because two groups are present in the unpaired t-test, whereas in the paired t-test only single group is present. That's why only n is written here. Now going ahead with the examples. First of all, we are dealing with this example. Now you have to identify that whether there is a paired t-test or unpaired t-test will be applied here. So systolic blood pressure of the 6 hypertensive patients were written as given here. After the administration of the particular drug for the week, the pressure were 175, 180 and respectively. Could such difference arise due to chance? So here you tell only that two groups are present, or it is a before after study. Obviously it is a before after study, because before this was the blood pressure, after giving the drug this was the blood pressure. So we will make the table accordingly. So first of all we have to write this table. It is the basic table that should be written from the question itself. That is, before giving the drug the blood pressure is, after giving the drug the blood pressure is written here. Now what is D? Now D is whether it is x1 minus x2 or it can be x2 minus x1. It depends on the scenario. Here, since majority of the x1 values are bigger than the x2, we are doing x1 minus x2. But there are some examples as well in which, for example, the diet type ration is an example in which x2 is generally greater than the x1. So in that we can write as d2 is equal to x2 minus x1. Ultimately we need the value of d to be positive, so that the d bar can be positive and we get the value of the t-test as a positive value, which I will explain in the later scenario. So d is equal to x1 minus x2. So just subtract this and we will get the answer, that is 4, 10, minus 4, etc. Then considering the negative signs to calculate the sigma d, after adding all these values we get the 30 as our answer. Then we find out the d bar. What is d bar? D bar has been written in the previous formula, that is sigma d divided by n. Okay. Then by applying this formula, it is sigma d by n, that is 30 by 6 is equal to 5. Now another table, another column we are making, that is d minus d bar. Now we get that the d bar value is what? D bar value is 5. So by just putting the d value which we got from here and 4 minus 5, that will get minus 1. Similarly 10 minus 5, we will get 5. So similarly we have to put and calculate all the values, and all the values are already calculated here. After that the next step is do the square of this d minus d bar. So when squaring is done, the negative sign will be eliminated. So respectively I have written all the values here. Now also do summation of all these values, that is sigma d minus d bar whole square, that is equal to 332. Most importantly, we have to consider the negative signs for the sigma d while calculating and adding the d's. That is, here I have included the negative sign. Okay. Then what is the study hypothesis here and what is the null hypothesis here? So the study hypothesis is the differences in the blood pressure after giving the drug in the next week are statistically significant, and in the null hypothesis it is opposite to the study hypothesis, that the differences in BP after giving the drug are not statistically significant, means it have arisen only due to the chance. Now applying the standard deviation formula, which I have already taught in this here, that standard deviation for the paired t-test is sigma d minus d bar whole square divided by n minus 1. So applying the same formula here, 332, which I have already calculated from the here. So just apply n minus 1, that is 6, which is a sample size in this case, that is 3 and 3. So 6 minus 1, that is 5. On calculating we get standard deviation, that is equal to 8.149. Now just we have to put the values in the t-test formula, that is t is equal to d into root n divided by standard deviation, that is equal to 5 into root 6 divided by 8.149, and after putting the values we get this answer. Also as a step we have to add that the degree of freedom is equal to n minus 1, that is equal to 6 minus 1 is equal to 5. Now we have to compare with the values written on the blackboard in the exams, because even it is difficult for me as well to specifically find at a probability 0.05 and degree of freedom 5 from the t probability table, and in the exam it will be already given in the question paper that from which we have to compare the values and justify the correct hypothesis, as I taught in the previous lectures as well. Now going ahead with the next example, that is, two types of rations are fed to the guinea pigs. A sample of pigs, 12 pigs, is fed type A ration, whereas another sample of 12 pigs is fed type B ration. The weight is given in the gram in each case, that is, increase in weight after giving the particular ration is given here. Now we have to compare the weight gain after feeding of the two types of ration. So let's see. Here type A ration is given and here type B ration is given, and respectively the weight gain in the grams is given for the guinea pigs. Now from the question itself we are getting to know that here another sample is written. If the question says that another sample is written, then most likely it is two groups we are talking about, and when there is a two groups, two people wants to unpair whereas the single people wants to pair. So likely, because here two groups are present, here will be an unpaired t-test which will be applicable. Now for the unpaired t-test we have to make two tables, first table for the first group and the second table for the second group. So for the ration type A, the weight gain is written here. After that we have to just summate all these values to get the sigma x, which here is 384. Then x bar is calculated as sigma x divided by n is here 12. Putting values we get 32 answer here. Now making column of the x minus x bar, here the x bar is 32. So applying this column table we get the 31 minus 32, that is minus 1. So similarly on calculating we get all these values. After that we have to just put in the square of this x minus x bar square, and then we will remove the negative value and we will get all these positive values. And on summating all this, that is sigma x minus x bar whole square, we will get the 116 as our answer. After that we will get the standard deviation. Why we have taken as a square, we will learn about this, that why I have not taken under root here but keep this under root on the left side of the equal to sign as a square. So S1 as standard deviation square is equal to sigma x minus x bar square whole square divided by n minus 1. On putting the values we get the standard deviation square as 10.54. Similarly, like the same we are going to do for the group 2 as well, that is same thing I have done here, and by the similar way I have calculated the y bar, then make a column, that is y minus y bar, then y minus y bar whole square, and then calculating the standard deviation square of the type B ration as well. So why I have calculated the square instead of being the standard deviation, because in the pooled deviation formula standard deviation square is written. That's why I have not calculated the square root and put the square root on the right side of the equal to sign. So on putting the values in the pooled standard deviation I got, that is standard deviation square n1 plus standard deviation 2 square n2 divided by n1 plus n2 minus 2. On putting the values I get the pooled standard deviation, that is 3.27. Now we got all the values, just we have to put the values in the formula of the unpaired t-test, that is t is equal to x bar minus y bar divided by standard deviation under root of 1 by n1 plus 1 by n2. On putting values we get the answer as 2.25. Also here the degree of freedom, which is a necessary step in the biostatistical exercise, that is n1 plus n2 by minus 2. On 12 plus 12 minus 2 we get the answer as 22. Now we have to just compare the values which is written on the blackboard in the exams and justify the correct hypothesis. I already taught how to know when there is a less than, when there is a greater than, and when there null hypothesis or study hypothesis is accepted. So one thing which is remaining here, that what is study hypothesis and what is null hypothesis in this question. So as from the mean I calculated that the x bar is 32 and the y bar is 29. From the study results I come to know that type A ration increases the more weight gain than the type B. So from this, which can I see that the mean of the type A ration is 32, weight gain is more. So I can say that in the study hypothesis the type A ration increases more weight gain than the type B ration, whereas in the null hypothesis the type A ration doesn't increases the more weight gain than the type B ration. means that it is merely by chance only. So it is most difficult out of all the three types of the biostatistical test. I already know, but I tried to simplify. I hope so it will be helpful to you all. And so that's all for the today's video. We will meet soon in the next video. Thank you.